Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with RF Elements. Today's host is Tassos Alexou. He is their product evangelist and antenna expert. He'll be presenting today, and if anyone has any questions, please submit them in the question box, and I'll ask them of Tassos at the end of today's presentation. Tassos, thank you so much for being with us today. Appreciate your time. Looking forward to what you got to share with us today. You can go ahead and take it on over.
Excellent, thank you. Thanks for having me. My name is Tassos with RF Elements, and today we'll be doing our product overview. So we'll be discussing our current product line, where it is right now, the advantages, and what makes it distinctive between the different products that we offer. So if we look at our current product map, we have our products broken into three different categories. The first category is antennas that have symmetrical beam shapes, right? So all the beam patterns from these antennas are symmetrical. And then we have it broken down further to our asymmetrical beam antennas. So these are, again, antennas that have RF beams that are asymmetrical and don't match. And then finally, we have our twist port adapters. These are the adapters that work with the third-party radios that are on the market and help convert them into waveguide fed radios for our twist port enabled antennas. So in starting, we'll start with our twist port adapters. Again, we make adapters for many different manufacturers out there. So we'll go through the things that make these adapters unique and how they work. So this right here is actually our twist port. This is actually the connection interface. It's our proprietary waveguide connector design that is the interface for radios into our twist port antennas. So it's a very unique form factor and very unique connection point, unlike the conventional radios with coaxial connectors. So we brought the idea of zero loss in the radio platforms about 4 years ago, where we said, if you can, take the coaxial connectors off the radio, right, and integrate the waveguide feed lines onto the actual radio board itself, you could have, virtually zero loss. It's pretty much, unmeasurable, the amount of loss that you have compared to using connectorized radios with coaxial connectors. So from that design and from that concept, we came up with, our twist port adapters, right? So the market is currently filled with connectorized 5 gigahertz type radios. So we simply created an adapter that has the pigtail connectors internally to interface a connectorized radio and make it a near zero loss waveguide fed system to connect to our twist port antennas. So for those of you who aren't familiar with our product line, these are our different types of twist port antennas. We have everything from like point-to-point or CPE parabolic dish antenna types to high gain horn antennas to our symmetrical and asymmetrical horn antennas, which are typically used for point to multipoint. The thing to really know is that our twist port adapters work with any of our twist port antennas. So it doesn't matter which radio and adapter you use, they are 100% compatible with all of our twist port enabled antennas. So we talked about the different radio platforms that we currently have support for, and Cambium Networks is one of those radio vendors. So we have a complete line of twist port adapters for many of their radios. So if you're using the old PTMP 1000 radio, then we have a twist port adapter for that radio. Again, it's quite simple. Your connectorized radio just slides and locks up in place inside the twist port adapter, protecting the coaxial connectors from outside rain, water ingress, and birds and other things that can degrade or reduce the quality of your connection. If you're running the EPMP 2000 radio, again, we have another unique adapter specifically for the EPMP 2000 radio only, that again will convert that into our TWISTPORT waveguide form factor, allowing you to use it with, again, any of our TWISTPORT enabled antennas that we offer. If you're using the new EPMP 3000 CSM, this is the CPE, connectorized CPE antenna, I believe, from Cambium Networks. Again, we have a specific TWISTPORT adapter for that radio that will, again, allow you to convert that into a waveguide form and then connect to, again, any of our TWISTPORT enabled antennas. And then lastly, we have the EPMP 3000L. Actually, this radio and the 3000 CSM are actually the same exact form factor. So this one adapter will work with both of those radio systems. So again, all our radios just simply slide up inside to the adapter and automatically they lock in place. Then it allows you to take that radio now and connect it to any of our TWISTPORT enabled antennas. And then simply just by pressing the release button, if you need to remove it, it's a simple press on that button and the radio just drops out. So quite simple to use. And again, it really helps improve a lot of things on your network. If you're a Microtech user, we have a couple of TWISTPORT adapters for basically your 911 type series radio board. So any of the old 411, 711, 911, and even the current M11 series of boards from Microtech, they're basically small square form factor, work with this RBP, router board plastic TWISTPORT adapter. So again, it's quite simple. The radio slides up inside the adapter and then converts it over to a waveguide fed system, allowing you to connect it to any of our TWISTPORT antennas. For those of you who use the same Microtech boards but are looking for maybe a more survivability in a more harsh environment, we have the all metal or all cast aluminum version of that same adapter. So with this one, again, gives you better EMI protection, better protection with an O-ring seal for more harsher environments. So the RBC is the TWISTPORT adapter you would need for Microtech. If you're a Ubiquiti Networks customer, again, we have probably the largest line of adapters for Ubiquiti Networks. So the first one is a TWISTPORT adapter for ISOSTATION. So this is basically a converter where it converts Ubiquiti's waveguide fed radio system into our waveguide connector form factor. So again, if you're using any of their ISOSTATION or PRISM station, basically those round form factor radios from Ubiquiti, the one adapter will work for all of those different radios, whether it's the ISOSTATION M5, the 5AC, or the PRISM 5AC, one adapter for all. If you're using the Ubiquiti Rocket Prism or the AirFiber 5X series of radios, this one adapter, the path, works for both those radios. So here you can see the AirFiber 5 adding this clip-on adapter to then allow you to clip it into this one adapter. So again, one adapter for two different radios from Ubiquiti. Another really neat thing about this particular adapter is we were able to integrate the GPS puck, or actually the mounting slot for the GPS puck. So we know that a lot of users out there have issues finding a proper mounting location for the GPS antenna. Also, the GPS antenna is often attacked by birds and other things that like to chew on it and everything. So by mounting it inside, we're able to not only protect the RF connectors from signal loss, but also the GPS as well, which is a pretty big part of the Ubiquiti radio system. So a really cool feature that we've added to this particular twist port adapter. As far as compatibility goes, again, whether you're running the Rocket Prism 5AC, the 5AC Gen 2, the older AirFiber 5X, or the newer AirFiber 5X HDs, this one adapter works for all those different radios. The same form factor as one adapter. And then finally, for people who are running legacy Ubiquiti radios, like the older Rocket M5 radios from Ubiquiti, we have again a unique adapter for that radio, as well as the Rocket 5 AC Lite. This is the first generation AC radios from Ubiquiti. So two more unique adapters for those different radio platforms. And then finally, if you're a Mimosa Networks customer, we have a single adapter for the C5C radio from Mimosa. So again, just like all our other radios, the twist port adapters allow the connectorized manufacturer's radio to slide and lock up into place, and then makes it compatible with all of our twist port enabled antennas. The final adapter is our connectorized twist port adapter. So this is basically for all other radios out there. So our twist port antennas can work with any manufacturer's 5 gigahertz radio. The difference here is if it's not a small form factor, like let's say for instance you're running the Cambium PMP 450i, or the Mimosa Networks A5C, or even the Cambium EPMP 3000 radio, where we do not make a connectorized, where we do not make a twist port or slide and lock in place twist port adapter, we have the connectorized adapter. So again, it's quite simple. It just gives you two SMA connectors that you can use your own SMA to N or SMA to SMA LMR jumpers to go to, again, any other 5 gigahertz radio system out there that does not have a twist port adapter. This would be Microtech net metals and net boxes and you name it, Radwin jet units, or again, any other connectorized radio that's in the 5 gigahertz spectrum that we do not have a specific twist port adapter for. You would use this connectorized SMA adapter. So that pretty much sums up our different twist port adapters. Now we'll move into our actual antennas. So the next one on our list is our symmetrical horn Generation 2 twist port antennas. So for, again, those of you who've never seen a product before, again, this is the what the horn antennas look like, our twist port horns. We have many different versions. We have 7 of them, and everything from, again, 30 degrees wide in azimuth to 90 degrees wide. So we'll talk about what makes these horn antennas very unique and very special for the 5 gig spectrum. So the first thing is that, again, it has a symmetrical beam. And what this really means is that the elevation cut and the azimuth cut are the same. So the pattern is very symmetrical. Your beam height and beam width are the same. So in this case, we're looking at a 30-degree symmetrical horn. The beam pattern is 30 degrees wide and 30 degrees tall. And at the same rate, the 90-degree symmetrical horn would be 90 degrees tall and 90 degrees wide. So symmetrical only represents, again, the shape of the beam that both matches in elevation and in azimuth. So if we were to compare this beam to a traditional sector, as you see on the left, again, you can see a very big difference in the beam. The one thing you notice is that there's no side lobes, right? So not only is the beam symmetrical in shape compared to the asymmetry of a traditional sector, but you see that our symmetrical horns have absolutely 0 side lobes, unlike the traditional patch array sectors that most people are using. And these side lobes, or lack thereof side lobes, make all the difference in the noise isolation and co-location capabilities of our horn antennas compared to all the other antennas on the market today. This here is a 3D simulation, or a simulation of what the RF propagation looks like when it comes out of an antenna. So again, on the left, you're seeing our 90-degree symmetrical horn, and you can see again how the beam pattern is very symmetrical, and we have practically zero back isolation and no side lobes. When you compare that to, you know, your run-of-the-mill patch array sector antenna, you can see that there's tons of side lobes and a lot of RF energy is leaking at the back. I mean, this sector here is practically an omni. It's not really a directional sector at all. So zero side lobes really give you the ability to co-locate these antennas next to each other, and therefore build out your coverage of high density horn antennas versus your traditional patch array sectors. Because we have a typically larger elevation cut or elevation beam pattern, symmetrical horns have close to zero or very small null zone. This is the dead zone underneath the tower. So the higher you go on a tower or your mounting structure, the larger the dead zone is underneath your traditional sector. So here you can kind of see in comparison the ratio of the dead zone of a symmetrical horn versus the dead zone of a traditional sector. So your close-in coverage is covered. If you're in a deployment where the topology is, you know, very diverse, right? You have lots of hills and valleys and stuff. Horn antennas typically help you cover the close-in clients and the far-out clients with one antenna without the need of two sectors, one with extreme down tilt for your close-in customers and one with less down tilt. So a highly efficient antenna from that standpoint and that type of deployment. Another great benefit is this frequency stability of horn antennas, or our horn antennas, versus traditional sectors. So here you can see as we kind of sweep through the frequency from the lower 5 gig up into even 6 gigahertz, you can see that the main part of the beam is barely changing. The deviation of the coverage area is quite small. That's probably better shown in the two-dimensional plot, or the two-dimensional coverage area you see on the right there. So again, as we change frequency, you can see that the coverage area is barely changing no matter where you are in the 5 gig spectrum. If we look at a traditional sector, you can see that the frequency stability of a patch array sector is huge. So as we go ahead and sweep through the 5 and even up into the 6 gigahertz, you can not only see the coverage area of the sector changing, but you also see the size and complexity of the side lobes grow as well. So this is really a very unstable antenna type for a very wide frequency range spectrum like 5 gigahertz. The bigger portion, again, if you look at it in two dimensions on the right, you can see how that coverage area is changing. So you may be on one frequency where your customers are fine, and then later noise comes into play, and you're forced to change your channel, and all of a sudden you have customers that were had good signal that no longer have good signal, and you wonder why. Most people usually say, oh, you probably have noise in that new channel, despite your spectrum scan not showing any. The really reason for it is because the coverage area changed, so you're not getting the same intensity signal at that particular CPE in one frequency versus another. So this is why patch array sectors are not the best antenna technology for 5 gig in such a wide spectrum, wide operating spectrum. And finally, signal density, again, is another unique property. This is how fast the signal falls off as you move away from the center point of the antenna. So a horn antenna, again, as you move towards the edge of its 30, 40, 50, 60 degree beam angle, the signal drops off very fast. On the right, you can see traditional sectors. Just like any antenna, the beam or the signal intensity drops the further you go from the 0 point or the bore side of the antenna. The difference in a patch array antenna, the bleed off is much, much, much slower, right? And this is why a lot of people you'll see out there use 120-degree sectors as 180-degree sectors, or 90-degree sectors as 120-degree sectors, because the bleed off is so slow. And it's because of this slow bleed off that you start getting, again, interference from your co-located sectors, because again, they start spilling over into your other coverage areas, and you get zero precision out of a patch array sector, where with the the really good signal density of a horn, you get very precise radiation angles, and therefore very good coverage patterns. So I mentioned earlier the different versions. So we have everything from a 30-degree symmetrical horn up to a 90-degree wide symmetrical horn. The thing that's really important to understand here is the gain relationship to the beam angle. You can't just take a 90-degree sector, patch array sector, and replace it with a 90-degree symmetrical horn. You have to understand the gain difference between the two, right? So our 90-degree symmetrical horn only has 9.5 dBi of gain. So if you're trying to replace a 19 or a 17 dBi patch array sector with this 9.5 dBi horn, you're not going to get the same coverage distance, because the gain is so much smaller. So you just have to understand, as you go wider in the beam angle, your gain starts to drop off. And there's reasons for this. Particularly the symmetrical horns work, the 90-degree or the wider ones work great for kind of hotspot locations or micro pops, where you're basically not trying to go great distances. Again, the lower gain gives you great noise immunity, where again, traditionally people are using sectors for these micro pops that have too much received gain for going such distances. Therefore, they hear so much more noise. So again, 7 different beam angles, everything from 30 to 90 degrees in 10-degree steps. Our horn antennas are, again, they're very compact in size. So actually, they're about 1/3 to 1/4 of the size of your traditional sector. Therefore, you're able to get 2, 3 to 4 times the AP density in the same vertical mounting space of your traditional sector. This is highly important, because as the number of internet connections that you need to deliver starts to increase, you need more and more access point density on your tower, and symmetrical horn antennas give you the ability to co-locate so many more antennas in the same vertical space as a single sector. Therefore, you're able to tightly cluster and get, again, this kind of co-location miracle, right? The ability to mount so many different, a vast number of horn antennas on a single tower, therefore getting you the AP density you need for the higher throughputs you need to deliver, with none of the side lobes, none of the noise, and none of the problems that traditional sectors give you, where all the side lobes, the more sectors you add, the more side lobes you're creating, therefore the more noise you're creating for yourself. So it just doesn't scale like symmetrical horns do. Here are some pictures of real life installations in the field, right? So, I mean, it really is a co-location miracle. People are putting pretty much a dozen horns, a dozen APs on a tower is kind of the standard today, and it's growing. We have up to 36 APs on one tower, all coexisting and working fine with GPS synchronization. As long as they're used properly. You can also see how close they can be mounted. I mean, typically they're about 1 foot apart. So on the right, you can see where 3 30-degree horns are taking the place of 1 90-degree sector. And again, the co-location capabilities of these horns are unmatched in the industry today. And again, this all gives you massive scalability. Again, the key here is delivering more access points per tower, because the number of internet connections you guys need to deliver as a WISP is growing, and the radios today are still working on the same kind of 10 to 30 subscribers per AP. So the only way to get more subscribers per tower is to add more access points, and the horn antennas give you that massive scalability that you need to compete in today's market. our antennas are really well built. Those of you who have used it know, and those of you who haven't, once you see it for the first time, you'll see how well built they are. We use all high quality stainless steel, aluminum, and UV rated plastics, right? So these antennas are built to last and to stay. Again, just some more pictures of some deployments out there in the field, again, to just show you how they're tightly co-located and how well they work with each other. So it's really, really incredible, really incredible. So from the symmetrical horn twist port antennas, we're going to go to our ultra horn twist port antenna. So the ultra horn is really designed as it's a very high gain, horn antenna. This one has a 15-degree symmetrical beam, so it's 15 degrees wide and 15 degrees tall, and actually delivers 24 dBi of gains. This is very high gain for a horn antenna. As I mentioned before, again, it's a symmetrical beam, so the azimuth and the elevation cut are the same, making it highly precise. Like our previous antennas, the symmetrical horn antennas, our ultra horn still has the same frequency stability. So again, as you change channels from the lower 5 to the upper 5, you know that the beam pattern is not changing. You're not increasing side lobes and therefore allowing your radio to hear more noise. Again, it's a very stable radiation pattern, therefore giving you extremely stable performance. No side lobes. On the left, you see what a parabolic dish antenna looks like in all its side lobes and all its glory. Again, if we were to cut it in 2 dimensions, you can see the kind of two-dimensional polar plot that you're used to and how large those side lobes are. The higher you go in gain on an antenna, the higher the gain and intensity of the side lobes are. So when you're talking point-to-point antennas that are 20, 30, plus dBi of gain, those side lobes are actually quite large and make it very difficult to co-locate the antennas on towers. Plus, if you have backhauls that are closely populated within a mile radius or something like that, it too can create noise and issues. Where on the right you see the ultra horn has absolutely 0 side lobes, so very, very directional and very, very good noise immunity. Actually, we have customers doing point-to-points with ultra horn without GPS synchronization and utilizing the same channel on towers. So it's quite amazing what it can do. So a lot of people like to put shrouds, these kind of drum things around the outside perimeter of the dish to give you the illusion of side lobe suppression. And quite frankly, it's not the case. It's just moving it. So this is what we call the shroud effect. What we have here is the simulation of a parabolic dish antenna on the left without the shroud. So here you can see, again, all the side lobes and how complex they are. So this antenna should have a basically 10-degree beam angle, which people think, hey, it's very narrow, therefore it's great noise isolation. But you can see clearly the antenna radiates in 30 to even 40 degrees wide and beyond if you look at the end. On the right, you can see the same antenna with a shroud put on it. So all the shroud does is really just move those side lobes forward some. So it does give you better front to back. It does give you some co-location capabilities, but it actually doesn't eliminate your side lobes. The side lobes are still there. You're still able to hear lots of noise at distance and create a lot of noise by using a very, poorly efficient directional antenna in its place. Again, the main thing here is when you buy an antenna, you typically get your polar plot or your radiation angle, or you buy your antenna based on those specifications. Once you put a shroud on there, it totally changes that RF beam pattern. So you no longer can depend on the polar plot that the manufacturer of the antenna gave you, because it's no longer valid. When you put a shroud on it, you change the RF characteristics, and therefore the beam is no longer matching what you currently bought. So it pretty much changes everything. And again, in 3 dimensions here, you can see all the shroud does is just basically take all those side lobes, not eliminating them, just smushing them together and actually making it more forward facing, and therefore actually making it more wider in the front cut. So not great, not great at all. It's more of a placebo. Here on the left, you can see an ULTRAHORN, right, compared to a parabolic dish antenna. So again, this is a 24 dBi ULTRAHORN compared to a 24 dBi parabolic dish. Again, even though the ULTRAHORN has a 15-degree wide beam compared to the spec 10-degree wide beam of this 24 dBi dish, you can see overall, because there's no side lobes, it's actually way more narrow, right? So again, don't be fooled by that main beam spec angle. You have to take into effect all the side lobes that are there and really how that affects everything as far as generating noise and receiving noise. So there's nothing better than an ULTRAHORN for point-to-point if, again, the gain fits the distance. Another thing that you get again is, the gain performance across the spectrum. So not only is the beam frequency stable, so as you change from the lower 5 gig to the upper 5 gig, the RF pattern doesn't change, but the gain also follows that, and in both polarities. So again, as you're changing channels with an ULTRAHORN, you can be assured that the gain of the antenna isn't deviating much from one frequency to another. Most parabolic dish antennas that you find out there, again, that 30 or 31 dBi of gain is usually at one polarity and at one very specific frequency. It's pretty much the maximum you'll ever see, and that's how antenna manufacturers usually spec their parabolic dishes. Again, a lot of antenna manufacturers no longer even put the gain plots in there. They usually give you a low, a medium, and a high number rather than show you the whole plot. So here again, as you change frequencies, again, you're getting pretty much the same intensity of gain no matter where you are in the 5 gig spectrum. This is really important, again, as you go into other unibands that may have lower maximum EIRP limits. So the gain performance and beam performance is unmatched on our horn antennas. It also makes it a lot easier to align your antennas, right? Because we have no side lobes, again, when you're using too high of a gain of an antenna, a parabolic dish, for too short of a link, you tend to have installers connect, instead of main beam to main beam, they go main beam to side beam, or even side beam to side beam, because again, the gain of the side lobes are so high that you can get the illusion of a good quality connection because of high signal intensity when it's actually a poor connection. So here on the left, you can see an ULTRAHORN, you're either in main beam and you have a link, or you're not, right? So no more hunting for that main beam through the side lobes and all the other stuff. Easy antenna alignment and more reliable connections. The final point is, really, is this a high performance point-to-point antenna, or is it really a really fine focused point-to-multipoint antenna? In the end, the antenna really doesn't care. It'll do whatever you want. The key here is, does the radiation pattern of the antenna fit your usage mode, right? So again, if you have a cluster of customers that are within the 15-degree beam angle of this ULTRAHORN, why not use it for point-to-multipoint? In fact, people are doing it every day now, using it for extremely highly focused, extremely high density point-to-multipoint, because it's actually quite amazing, and the gain of the antenna is quite high. So again, you could use it for point-to-point or point-to-multipoint. The antenna really doesn't care. The key here is making sure that if you use it for multipoint, that the customers or subs are within that 15-degree beam angle. Just like all our antennas, again, built with all high-quality products, from zinc alloys to stainless steel to aluminum and UV-rated plastics. Here again, we're seeing actually the ULTRAHORN used in point-to-multipoint. So in the left, in the center, you can see it's basically a 180-degree deployment with ULTRAHORN. It's quite amazing. It's possible. It's really up to you. On the right is a 15-mile EPMP 1000 point-to-point link. Again, full MCS 714, right? So it's full modulation rate at 15 miles with only 24 dBi of true, pure, perfect RF performance. You won't get that in a dish. Here again, some other deployments of them co-located with sectors and other antennas. So again, this is really becoming a very versatile antenna, where it was again designed for higher gain point-to-point, but now it's being utilized for point-to-multipoint. So quite amazing stuff. Finally, in our symmetrical beam pattern, we'll move on to our ULTRADISH. So our ULTRADISH is our twist port version of a parabolic dish antenna, right? So we have two different versions. We have a 400 and a 550 millimeter. The 550 is 27.5 dBi of gain, and the 400 millimeter is 24.5 dBi of gain. So there are some unique things that we've done to our dish, unlike other parabolic dish antennas out there. So they still have side lobes. You really can't escape that. The parabolic dish antenna has side lobes. It's part of the inherent design flaw of parabolic dish, but we're able to suppress them some, right? So we have very good side lobe suppression without the use of shrouds, and therefore we get really good performance out of them. The really important thing, or one of the most important things that we've done with our parabolic dish, unlike other manufacturers, is we ensured that the gain is as flat as possible across the entire spectrum. So again, as you go from the lower 5 to the upper 5, you're delivering pretty much the same amount of gain no matter where you're at, and again, in both polarities. So your vertical and horizontal gain are the same, and this helps ensure the chain-to-chain performance in these long-distance links. So whether it's the 400 or the 550 series, you're getting, again, flat gain and in both polarities across the entire spectrum. These antennas are being really well used as CPEs in high AP density deployments. So here you see patch array panel antennas that are used. They have lots of side lobes, and therefore they can detect and hear multiple APs in these kind of, again, high density, low distance deployments, where the ULTRAHORN with its suppressed, the ULTRADISH with its suppressed side lobes really make for great CPE antennas for these types of deployments. It's a very innovative mount. So again, I mean, it's really just 2 bolts is what holds it on the tower, and you're done. The antennas just slide into place, and then you can adjust your azimuth and then your elevation with just a few bolts. And again, everything is captive, just 2 bolts. So no more fiddling with nuts and washers and lag bolts and all this stuff on top of a tower to mount your dish antenna. 2 easy bolts, and you're done. So very innovative, very different from everything else that's out there on the market for sure. Again, here are some deployments. You see some point-to-points and even CPE antenna uses for the dish. So again, it's really kind of up to you and your WISP's budget, basically. So we've been discussing symmetrical beam pattern antennas. Now we're going to asymmetrical. So this is our new asymmetrical horns. So again, they're still twist port enabled horn antennas. The difference is that, again, the beam shape is asymmetrical, meaning that they're no longer as tall in the elevation as they are wide in the azimuth cut. So we have basically 3 different versions. We have a 30 degree, a 60 degree, and a 90 degree asymmetrical horn. And now you can see the increase in gain. So the 90 degree asymmetrical horn now has 16 dBi of gain versus the symmetrical horn that previously had 9.5 dBi of gain. So this asymmetrical horn is much better suited for potentially changing out versus a traditional sector. Again, there's a totally different comparison for asymmetrical versus the symmetrical. And our 30 degree asymmetrical horn has some very unique properties in that it can be adjusted to be either 20 degrees wide for even more density or 30 degrees wide, and we'll talk about that here. So again, the shape of our asymmetrical horns is, again, no longer symmetrical. So this is 30 degrees wide, but only 20 degrees tall. With our beam shifting, you can also rotate it and make it 20 degrees wide or 30 degrees tall. So it's a difference of whether you want 12 or 16 of these on a tower, or 18. The 60 degree asymmetrical horn is 60 degrees wide and 20 degrees tall. And then our 90 degree is 90 degrees wide and 25 degrees tall. So again, that's where the asymmetrical horns are different. It's just in their beam shape. This is the beam switch feature we talked about earlier. So you can run it in one setup where it's 30 degrees wide and 20 degrees tall, or you can actually just remove the mounts, rotate it, and then operate it as a 20 degree wide and a 30 degree tall beam, right? So just shifting the way the antenna is mounted will change, again, the beam pattern in the field. So again, if you need really high density where maybe 12 30 degree horns isn't enough AP density for 360 degrees, you can operate this as a 20 degree wide one and therefore have 18 horns to cover 360 degrees, right? So it's really kind of up to you on how you want to utilize it, but we've given you this special feature to allow you, again, another tool in your toolbox and using it. Again, now, since it's asymmetrical and more like a traditional sector, we still have the small null zone, but you're really getting a very unique coverage pattern from it. It's more perfectly suited or better suited as a sector antenna than it was for the original symmetrical horns. Again, just like all of our horn antennas, we have absolutely zero side lobes. So again, now you can see an asymmetrical 60 degree horn, how symmetrical that beam pattern is, how it radiates the same way with no back radiation and zero side lobes compared to a patch array sector, right? So again, all the noise immunity of a horn antenna with none of the side lobes and problems of a traditional sector. Again, very frequency stable. This is very, very, very difficult to achieve. It took us time. But again, as you go from the lower 5 gig to the upper 5 gig, you're getting, again, a very stable coverage pattern. And therefore, you know that as you change channels, your customers aren't going to be falling in and out of your coverage area for that particular AP. Another thing that was very difficult to achieve, but very important for us to deliver on, was the balanced H and V beams, right? So the horizontal and vertical beam patterns are identical, unlike a traditional sector. So here you see the vertical and horizontal beam patterns for a traditional sector are usually mismatching, where one is wider than the other. So typically what you'll find is let's say a 90 degree traditional sector, you may have a vertical beam pattern that's 80 degrees wide and a horizontal beam pattern that's 100 degrees wide. And on average, it's 90. So they call it a 90 degree sector. This is fairly typical for patch array sectors. And in our asymmetrical horn, we made sure that the vertical coverage area and the horizontal, the vertical and horizontal beam patterns match. So therefore, you're getting the same intensity of signal in both chains, no matter where you are in the coverage area. The asymmetrical horns are great antennas for rural deployments, finally, right? So we now have a higher gain horn in a wider azimuth for those lower density installations. So previously, for rural deployments, you usually didn't have, or we found many customers that did not have the customer density to cover, again, 5 to 10 miles with our wider lower gain horn, right? So the only way to have covered that previously is with the higher gain, more narrow horns, the symmetrical horn series. Now you can cover those, again, low density deployments with high enough gain and wider azimuths for rural deployments, and then again have 0 side lobes. A lot of customers like to say, well, you know, I'm in kind of someplace rural and, well, we don't have any noise out here, right? And that might be true today, but I guarantee you in time you will have noise. Competitors will come in, density will grow, the noise will come. So now you can build your deployments, again, based on horns and noise immunity and not have to start it with sectors and then swap it out later. So good thing. Again, the coverage for rural areas, we still are able to deliver in the asymmetrical horns, very high user density as well. So again, it doesn't really matter where your deployments is, whether it's in very dense urban areas or in less dense rural areas. Again, you can kind of mix and match our symmetrical and asymmetrical horns on your tower as well to kind of fit the needs of your deployment. All our antennas, again, are very durable built, right? Using high quality zinc alloys, again, stainless, aluminum, and UV rated plastics. In finishing up our horn antennas here, the final series of horns is our carrier class horns. So the carrier class horns are really no different than the TWISTPORT symmetrical horns that we talked about earlier as far as RF performance goes. The difference is these antennas have end connectors built into them. So they no longer have, they don't have the TWISTPORT interface. So again, if you're a WISP that's running you know, only Mimosa A5Cs, or you're only running, you know, PMP 450Is from Cambium or something like that, there's really no need for you to buy a TWISTPORT horn and then the connectorized TWISTPORT adapter, right? So we have, again, these, you know, highly used horn antennas with the RF connectors built into an end connector. So again, we have everything from 30 to 90 degrees wide in 10-degree steps with all the same RF performance that we showed you previously. The same goes for our ULTRAHORN. So we have a carrier class series of ULTRAHORN. So again, if all your 5 gig backhauls are all, let's say, Mimosa B5Cs or Cambium PTP 550 or whatever it may be, again, there's no need for you to buy a TWISTPORT ULTRAHORN and then that SMA adapter. We have the horn as a single SKU with the end connectors built into it. So it makes it a lot easier for you. And then finally, again, you know, we see here some deployments with the carrier class horns. Again, here is some Mimosa point to multi-point. And on the right, we're actually looking at Cambium EPMP 2000. So currently, we have a TWISTPORT adapter for it. But previous to that, when we didn't have one, when the radio first came out, people just utilized the carrier class horn. So again, carrier class or TWISTPORT, the RF performance is all the same from the antenna itself. Therefore, again, it's just a difference of whether you want to have an extra adapter or not. So we're simplifying it. We'll also later may add to that line, let's say the asymmetrical horns will probably have a carrier class series as well. So finally, the carrier class sectors is the last of our asymmetrical beam shape antennas. So currently we have 2 patch array traditional sectors, so to speak. These antennas have been on the market. We've been making them for probably 6+ years now. We only have 2 versions right now. It's the carrier class 214, which is a 2.4 gigahertz, 14 dBi sector antenna. And then we have a 5 gigahertz, 20 dBi version of that same antenna. And these are both spec'd at 100 degrees wide at the -6. So most people use them as 90-degree sectors. Something that's very unique to our patch array sectors, and quite frankly, we were one of the earlier ones using it, is we have these frequency selective surfaces built in, this BACKSHIELD. So traditional sectors, a lot of people would buy very poorly designed, cheap sector antennas out there, and then they would spend just about the same amount of money on some poorly designed aftermarket shielding kit to help reduce the kind of RF signature of the side lobes. So what we did is we actually design the shielding built into the antenna, specifically made for that antenna, and therefore we get some very unique things. So we get very good front to back isolation with these frequency selective surfaces and our very unique back shield. But also what it's capable of doing, it allows us to better place, again, the overlapping vertical and horizontal beam patterns. So you can see, again, even our patch array carrier class sector still has very good vertical and horizontal beam coverage compared to, again, your traditional sector, which typically has one beam much wider than the other, and therefore you have problems when your customers get into those kind of edge of sector performance issues where the chain mismatches happen, where you have chain 0 at a much better signal than chain 1. Therefore, you get very unstable MCS rates and create a lot of problems. So even our old 6-year-old patch array sector antennas have much better RF performance from, again, the co-location capabilities because of the back shield, and then therefore the vertical and horizontal beam placement. So again, here's just some deployments of our carrier class sectors that are out there in the field today. So all in all, RF Elements is really setting a new industry standard, right? We've opened up the market and the eyes of customers to what true noise rejection is, right? That antennas really do matter, right? So it's one thing to have a radio that has all these great features and these high modulation rates and these theoretical fast speeds. If you don't have an antenna that's capable of delivering the same type of good RF performance, you're never going to see those numbers. So again, RF Elements is setting the new industry standard and pushing the limits on delivering high quality radiation patterns, noise rejection from their antennas. Also, the zero loss or near zero loss TWISTPORT ecosystem or waveguide FET. Again, we kind of brought that new standard to the industry, and people are listening and you're seeing it every day. And again, our horn antennas are the only thing out there giving you that real massive scalability that you need to build better networks and go ahead and get that kind of density out there. Again, all of our antennas, right, no matter what they are built really well, utilizing the same type of high quality stainless, aluminum, zinc, and other plastics and stuff like that. So no matter which antenna it is that we build, you can be assured that the quality of the materials used are great. Again, we use all stainless steel, so it's very, very important to make sure that you use an anti-seize lubricant, right? So it should be a well-known fact that stainless to stainless likes to gald, right? So they will bond together with friction, so you have to use an anti-seize lubricant. If you use an anti-seize lubricant, then you'll ensure that your mounts won't rust like you see with galvanized hardware that's out there in the field today. So again, stainless steel hardware gives you longevity of your product. As long as you use anti-seize, you won't have any problems in the future mounting and unmounting and moving the hardware. We also utilize more ecological packing, right? So a little green push from us, using recycled cardboard and less styrofoam in our packing, and minimal amount of cardboard that's needed for the product. We really have a lot of great content out there. Our YouTube channel is a great place to go ahead and find a lot of this content, whether it's customer testimonials, again, unpacking how-to videos, webinars, previously recorded webinars. Again, the YouTube channel is great. We can sit here all day long and tell you how great our product is, but it really doesn't count as much as when you listen to your brother and sister WISPs out there telling you how these antennas really have changed their WISP forever. Right, so we have some great videos out there. We also started up a new informational series called Inside Wireless. And Inside Wireless, we kind of teach you the, how antennas work, what gain is, and all these kind of simplified explanations for, basically what RF is and how it works. So a lot of great information. Please go visit our YouTube channel. We also have a active forum, rfelab.com, so it's a great place to go and again connect with other users of our antennas and hopefully discover maybe some solutions to problems you have, see how other WIPs have dealt with noise and growing pains and stuff like that. So rfelab.com, great place to go to get this information and connect with other users out there, all online. And finally, some trademark disclaimers. So again, just being clear that the third-party trademarks that we've used are solely used to reference the compatibility of RF Elements products with the other products, and all rights of these trademarks are reserved for the owners of them. And with that, we'll go to question and answer. So if we have any questions, if you haven't asked them yet, you have any, please type them in. For those of you who have, well, I'll take them now. I'm ready if you are.
Thank you very much, Tassos, for that presentation. And it looks like we do have a couple questions here for you. Let me go ahead and get started here. Let's see. First question. Are all of the antennas and TPA, do they only work for RF Elements so far? You did mention some brands, and are you expanding to additional brands?
Yeah, so okay, so all of our TWISTPORT adapters work with all of our TWISTPORT antennas. There are no other TWISTPORT antennas out there that our TWISTPORT adapters will work with because it's our proprietary interface. The only support we have outside of RF Elements is for which radios we support with a TWISTPORT adapter. So currently, Ubiquiti, Cambium, Microtech, and Mimosa are the only radio manufacturers that we have TWISTPORT adapter support for. Now, as far as the future goes, yeah, I mean, we're happy to consider other ones, right? So maybe you have some ideas or some manufacturers that we haven't seen or heard of. But yeah, definitely as new radios come to market that are 5 gigahertz and that are a small enough form factor for a TWISTPORT adapter, we definitely take into consideration supporting it. So if you have some ideas, maybe a radio we haven't seen that kind of fits the small form factor connectorized model, we'll definitely take a look at it.
Excellent. Thank you, Tassos. Next question here for you. With the adapters, the connect and use, do you need to make any software adjustments so they can work together?
Zero. It's all mechanical. So it's really nothing more than a mechanical connection from the radio to the TWISTPORT adapter and then to our antenna. So there's absolutely zero software change or anything that's needed. I mean, basically, if you're using any of the radios that are supported with our TWISTPORT adapter, you just slide it in and click it and use it with our antennas and you're done. So no software at all.
Thank you very much. Next question here for you. Does the metal enclosure cause any interference on the signal? For example, sometimes metal, brick, and other objects cause interference.
I'm not quite sure. I mean, I don't see how it would create any noise or interference. Sorry, I just don't understand the question. Maybe they can be a little bit more specific.
Okay, maybe they'll chime in and add to that. Next question here for you. Can the devices be ordered with customers' own logons on the TP-ADAP?
With their own logons? So we only sell through distributors like Microcom and others, right? So RF Elements does not sell direct, so there is no logon. I mean, you can find them on Amazon or through other distributors and stuff like that.
Thank you, Tassos. Next question here for you. Do you have visual representation on how all of your antenna frequencies spread?
So, I mean, we have a ton of information on our website. So there is some of that. We do share, and it's public on our website for download, the ANT files, the antenna radiation files for our antennas, for all of them. So you can simply go to our website and go to the download section of any of the particular products that you're interested in, and you'd have all the radiation for all the frequency on all our antennas.
Thank you, Tassos. Next question here for you. What is the longest link up and operational on the horn antennas?
Yeah, I mean, we always get that question. How far does the antenna go? I mean, that's too generic to answer. I mean, the longest one that I know, and again, this is by no means an accurate answer for everybody, because it's really very specific to what the EIRP limits are, right, for your specific area, what radio you're running, right, because not all radios have the same modulation scheme, right? So lower modulation rate radios will go further distances with the same amount of gain as another one because of the receive sensitivity. So to answer the question, the longest link that I know of is 15 miles with the EPMP 1000. Running full modulation rate with the ULTRAHORN at 24 dBi of gain, right? So that's the longest link that I know, but that doesn't mean that everybody can do 15 miles with our ULTRAHORN. It's, again, it's with a 64 QAM radio. So if you try and do that same link with an AirFiber 5 HD, you won't get full modulation rate at 15 miles, right? So the real answer is go to our website and go to our online link calculator, and then you'll see the furthest you can go with any of our antennas based on what radio you're running. That's really the right answer.
Excellent. Thank you, Tassos. Couple more questions here for you. The item HG3 TPA2030 has two numbers, 20 and 30. Which is the actual beam width, and why are there two numbers?
Right. So we discussed this earlier in the webinar. So the Generation 3 asymmetrical 2030 has a new feature which we call beam shift. So it's 20 or 30 degrees wide depending on how you mount it, right? So again, if you go to our website and you go look at that particular part you're speaking of, we actually have really cool videos and animations that show you how that works. So basically, if you mount it one way, the beam is 30 degrees wide. If you flip it 90 degrees or you switch the mount, then it's 20 degrees wide. So we call it the 2030 because it can be either or depending on how you mount it. I hope that's clear.
Excellent. Thank you, Tassos. A couple more questions for you.
Yep, no problem.
Do you have any plans to release a 60 gigahertz antennas?
Nope. I mean, really, this is asked quite often. There's no connectorized market for aftermarket antennas, right? Pretty much all the 60 gigahertz stuff that you see on the market today has integrated antennas. So a horn would be useless in today's ecosystem, right? So now, can a 60 gigahertz horn be good? Sure, right? But really the radio manufacturers kind of control all that, and most of the stuff you see out now, and I believe most of the stuff you'll see from the current players will all have integrated antennas, and therefore no 60 gigahertz antenna from us.
Thank you, Tassos. Couple more questions.
Yep.
Is the SIMPR radio still on your product roadmap?
Absolutely. It's been there forever. You know, again, that's our reference design of the zero loss system, you know, we've been talking about for years, and quite frankly, it's the, you know, the reference design that you currently see on the market from some other radio manufacturers. So it's definitely active. It's definitely a product that we're, you know, always considering and looking at and making better. When it comes out, no idea, nothing to share there on ETA, but it's most certainly on our roadmap. Absolutely.
Thank you, Tassos. Last question here for you.
Yep.
Is there a performance difference between the carrier class and the regular ULTRAHORNs?
No, absolutely not. So the antenna themselves are identical. So all the RF properties of the antenna, gain, beam, everything is the same between TWISTPORT and carrier class. The only performance difference that you might see are external to the antenna, meaning that if you use too long of an LMR run, if you use too low of a quality of LMR cable going from the end connectors on the ULTRAHORN to your radio, that's where you'll see a performance difference. The antennas the same or identical. The difference is when you use a twist port, you're using a extremely low loss, near zero loss interface from your radio to the antenna. So that's really the difference there. The antennas are identical.
Tassos, thank you so much for answering all those questions with us today. And also thank you to everyone for attending today's webinar. If anyone has any further questions, please feel free to contact your sales rep, or you can email us at sales@microcomtech.com. If anyone wishes to view any of the products mentioned and shown here today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded, and we will upload it to our Microcom YouTube channel so you can view it again. Tassos, thank you so much for your presentation and your time today. Greatly appreciate it. Until next time.
Yeah, thanks for having me, and stay tuned, everybody. Again, you can find us all over social media, so check out our YouTube channel, Facebook, LinkedIn, Twitter. Again, you could find us online. We'd love to hear from you, and thanks for joining. Take care.
Thank you.
Bye.